Hi guys, I'm Devika and I'm a student of Kendriya Vidyalaya in Aluva. Today I'm going to explain a scientific phenomenon with a small experiment. Here I have a balloon and a few pieces of paper. Now I'm going to rub this balloon against my jeans. You can also rub it against your hair if you want. And bring it closer to the pieces of paper. See? Why does this happen? How does this happen? Well, it's because of something called static electricity. Definition-wise, it is a buildup of an electric charge on the surface of an atom. It's called static because the charge tends to stay in one place rather than moving around. Thus, we can say that static electricity occurs when there is an imbalance of positively and negatively charged atoms. Now on to the theory part. We all know that matter is made up of atoms, and atoms are further constituted by three types of particles: negatively charged electrons, positively charged protons, and neutral neutrons. Generally, the number of protons and electrons in an atom is the same, so most of the matter you come across are electrically neutral. So let us know what happens when we lose either of these. Protons are tightly bounded, and so we do not generally lose these, whereas electrons are loosely bound and are small and insignificant in mass. So when these electrons undergo rubbing or friction, they gain enough energy to leave their atom and attach to other, migrating between different surfaces. One which loses electrons is now left with more protons and is now positively charged, whereas the one which gains electron is now negatively charged. This situation is called charge imbalance or net charge separation. But nature tends towards balance. So when these two oppositely charged substances come in contact, there is a natural tendency to neutralize these charged particles. So these mobile electrons may jump off the negatively charged atom, or may jump onto the positively charged atom to restore neutral charge equilibrium. This quick movement of electron is called static discharge. Now let us go back to the experiment I showed in the beginning to get a clear picture. So when I rub the balloon against my jeans, the electrons are transferred to the balloon, and now the balloon has surplus of electrons and is now negatively charged, whereas the pieces of paper are neutral, thus they attract. Now this doesn't happen with just any object you come across. A negatively charged particle should have surplus of loosely bound electrons for them to migrate to a positively charged particle. Thus, conductors show a great tendency, whereas insulators doesn't due to its tightly bound electrons. Though it can be a nuisance, it also has its number of beneficial uses. It is used in electrostatic precipitators, photocopier machines, and printers. In photocopier, static electricity is used to copy print to a page. One version of this device electrically charges ink so that it will stick to the paper in designated area. Another version of a photocopier uses chargers to stick the ink to a drum, which then transfers it to the paper. Lightning is also static electricity. Heavier negatively charged particles sink to the bottom of the cloud. When the positive and negative charges grow large enough, a giant spark lightning occurs between the two charges. Isn't it interesting? The uses of static electricity and its effects. It's been quite long since the effect of static electricity is known to the scientific world. Still, it's a curiosity, a nuisance, but it is also very important in our day-to-day lives. I hope you enjoyed this session. Thank you.